The first section we're going to talk about in this chapter is section 1.1, Introduction to the Practice of Statistics. The definition from your textbook for statistics is that statistics is a collection of methods for planning studies and experiments, obtaining information, and then organizing, summarizing, presenting, analyzing, interpreting, and drawing conclusions based on the information obtained. In addition, statistics is also about providing a measure of confidence in any conclusions we might come to. Now, the information referred to in the definition is data, and data is simply observations, things like measurements, survey responses, and so on, that describe the characteristics of an individual. In statistics, when we talk about an individual, we don't always mean a person. It depends on the population that we're studying. We may be studying a population made up of people, and in that case an individual would be a person. But we may be studying a population of fish in a lake, and in that case the individual would be a fish. Or we may be studying a population of businesses, in which case our individual would be an individual business. So when we talk about a population, this would be the entire group that we're interested in finding out information about. So this is going to be usually some type of large group, and for the most part it's going to be too expensive or too time consuming to get information about the entire group. So if that's the case, we select a small group out of our population, and that's called our sample. So our sample is a subset of the population that's being studied. And again, our population is made up of whether they be people or objects or animals. So we have our population, which is the large group. It's made up of individuals, and then the sample is a smaller group that's selected from the population. Now, when we're trying to identify populations and samples, here's some key concepts. If we're talking about a poll or a survey, the sample is the set of all those that were surveyed. The population is always a larger group than the sample. And if the sample is chosen from a group with specific characteristics, then the sample can only represent a population with those same characteristics. For example, if the sample is selected only from U.S. citizens, then the population represented by the sample can only be U.S. citizens. It can't be all people in the United States, since there are people in the United States who are not U.S. citizens. Here's an example. A Nielsen television survey of 4,000 households in the United States finds that 2,988 of them watched the final episode of American Idol. Let's identify the population and the sample. The sample, again, is going to be all of those who were surveyed. So this would be the 4,000 households that were surveyed. Notice, again, this includes all of those surveyed, not just the ones that watched American Idol. So the 2,988 number in is data that we collected from our sample, but it is not the entire sample. Now, the population represented by this survey is all households in the United States. In this case, our individuals are households instead of people. So the population that's represented is households in the United States instead of being people in the United States. And also, the sample doesn't represent households in other countries because we only selected from households in the United States. Here's another example. A newspaper article reports that the president's approval rating is 33%, according to a Gallup poll of 1,022 adults in the United States. So again, if we want to identify our sample, the 33% is data that comes from our sample, but that's not our entire sample. Our sample would be all of those who were surveyed, so it would be the 1,022 adults. The population represented by this survey would be all adults in the United States. Again, that's who our sample was selected from, so this sample does not represent all people in the United States because children weren't included in the selection process. Also, it doesn't represent adults in other countries because, again, the sample was only selected from adults in the United States. Now, sometimes we can obtain information about the entire population, and in this case, instead of being called a sample, this is called a census. It will be very important in later chapters in this course to distinguish between samples and populations and between statistics and parameters. When we talk about a statistic, it's some kind of numerical measurement that we calculate from our sample data. So it's going to describe some characteristic of our sample. So sample and statistic go together, and notice that they both start with the same letter S. If we have a census and we can collect information about the entire population, then any numerical measurement that we get from the census is called a parameter. So a parameter is some type of calculation that gives us a numerical measurement describing a characteristic of a whole population instead of just describing the sample. So population and parameter go together, and notice again that they both start with the same letter P. So if you're trying to remember which word goes with which, just remember that sample and statistic both start with S, population and parameter both start with P. Here's an example. Suppose the percentage of all students on your campus who have a job is 84.9%. Well, here we have a numerical measurement, so we want to determine whether this is a statistic or a parameter. Since this came from data about all students on your campus, that would be coming from a population. So that would make this number, the 84.9%, a parameter. Now suppose we have a sample of 250 students, and from this sample we find that 86.4% of our sample have a job. Well, again, we have a numerical calculation that gave us the 86.4%. That was determined from the sample data, so that would make the 86.4% a statistic. There are two major topics in this course when we're talking about statistics. The first one that we'll talk about in the first few chapters is called descriptive statistics. This just consists of organizing and summarizing data. We'll do that using numerical summaries, tables, and graphs. In the second part of the course, we will talk about inferential statistics. And this uses statistical methods that take results from a sample and extend them to the population. We also have some methods to measure the reliability or the confidence that we have in our results. The list of observations a variable assumes is called data. For example, while gender is a variable, the observations, which would be male or female, are actual data. So the first type of data we're going to talk about is quantitative data. And quantitative data always has to be numerical. So this gives us a numerical measure of some characteristic of an individual. We can do arithmetic operations, addition, subtraction, multiplication, and so on quantitative data. And when we do that, we get meaningful results. Some examples of quantitative data would be the number of students taking math courses at ACC this semester, or the ages of hospital patients. The other type of data is qualitative, or sometimes we call this categorical. This gives us a classification of an individual based on some characteristic. In other words, it puts the data into categories. So qualitative data may be in numerical form or it may not. Some examples of qualitative data would be the genders of professional athletes. So we can separate that into two categories, male or female. The rankings of college football teams. Again, we can separate into categories depending on the rankings that they have. And age categories of hospital patients. If we ask them which category they're in, under 18, 18 to 35, 36 to 54, 55 and over, that makes it a qualitative variable or qualitative data instead of being quantitative. Remember back here we were saying that the ages of hospital patients was a quantitative variable. That would be if we asked each patient their age and they just gave us a number. Whereas qualitative would be if we asked them which category of age they were in. So anytime that you are putting values into categories, that makes it a qualitative variable or qualitative data.